So next measuring instrument is optical square. So optical square is an accessory to the optical measuring instruments such as autocollimator, angle decker and alignment telescope. So this figure shows the optical square used with alignment telescope. It consists of a pentagonal prism which produces a 90-degree deviation to an accuracy of 1 second of arc. That means 0.005 mm per meter. Sometimes it is not possible to align an autocollimator to obtain a reflection from the surface to be tested. In such cases, the optical square is often used. So optical square is a constant deviation 5-sided prism which reflects rays of light through the same angle irrespective of the angle of incidence. The two reflecting surfaces have a 45-degree included angle. In the general case of a constant deviation prism, the ray of light is deflected through twice the angle between the reflecting surfaces. So the angle of deflection is 2 into 45 degrees, that means 90 degrees. The rays of light are therefore turned through 90 degrees without necessarily setting the square precisely in relation to the light. When used with an autocollimator, the optical square enables both the projected and reflected beam of rays to be turned through a right angle without precise setting of the square. This is very useful in alignment tests involving two surfaces at the right angles. Okay, and the next spheres and rollers or balls and rollers. So generally these balls and rollers are used to determine both linear and angular dimensions in conjunction with gauge blocks. Okay, so these are made of good quality steel and are hardened and tapped. So the length of the roller is equal to the diameter. The balls and rollers are available in sizes ranging from 1 to 25 mm diameter. So the use of precision balls and rollers for determining both linear and angular dimensions. Okay, suppose if you want to find out the angle of tapered piece, so by using these rollers of different sizes or slip gauges and dial indicator, we can measure the angle. So here the two rollers whose diameters are known and slip gauges are placed on the surface plate as shown in this figure. So the rollers may be clamped in position against an angle plate by using some C clamps. So the work is then placed on the top of rollers and clamped against the angle plate. If the angle of piece is alright, then the top edge will be parallel to the surface plate and the dial indicator will show no variation when traversed along its surface. So see this figure. With reference to this figure, from triangle O1 A O2, so tan theta by 2 equal to O1A opposite side O1A by AO2. So that equal to d2 by 2 minus d1 by 2 by 1 plus d1 by 2 plus d2 by 2. So tan theta by 2 equal to d2 by 2 minus d1, so sorry, d2 minus d1 by 2l plus d1 plus d2, where L, here L is the length of a slip gauge pile and d1 and d2 are diameters of rollers. So from the above equation, the slip gauge length L equal to d2 minus d1 by 2 by tan theta by 2 minus d1 plus d2 by 2. Okay, thus initially the length of the slip gauges is calculated by the above equation, and the rollers are placed just in contact with the slip gauges. By using this, we can easily find out the angle with the help of theta. Okay, and next we will find out the or we will check the angle of taper by using the rollers and the slip gauges. So this figure shows the method of checking the angle of taper plug gauge using rollers, micrometer and slip gauges. So taper plug is placed on the surface plate. The first two rollers of equal diameters are placed touching on the opposite sides of the lower surface of the plug on the slip gauge combinations of equal heights h1. So the distance m1 between the ends of the roller is measured with the micrometer. Then the rollers are placed on slip gauge combinations of height h2 touching on the opposite sides of the top portion of the plug. The distance m2 between the ends of roller in this new position is again measured by means of a micrometer. The half the taper angle of a plug is calculated. That means if d equal to diameter of roller, then tan theta by 2 equal to m2 minus d by 2 minus m1 minus d by 2 by h2 plus d by 2 minus h1 plus d by 2. So tan theta by 2 equal to m2 minus m1 by 2 into h2 minus h1. Okay. Okay. So next thing is sine bar. Next concept is next instrument is sine bar. So device. So it is a sine bar is a precision angle measuring instrument which is used along with the slip gauges. So what we do is here is a slip gauge. So you put the slip gauges at one end of the roller, you put the slip gauge. So basically what you do is you keep on height. So and here what you do is you this it is a flat surface, so now you place it on an incline, and then you put the workpiece here, then the dial to find out what we say is the theta, to find the theta. So we have to find out the theta. So generally it's a precision instrument to measure the angles very accurately and to locate the workpiece to a given angle within a closed limits. So generally it consists of a steel bar and two rollers. So the sine bar is made of high carbon, high chromium corrosion resistant steel, which is suitably hardened and precision ground and stabilized. The rollers are of accurate and equal diameters. They are attached to the bar at each end. The axes of these rollers are parallel to each other and also to the upper surface of the bar. The normal distance between the axes of rollers is exactly of about 100 mm, 200 mm or 300 mm. So when the rollers are brought in contact with the flat surface, the top of the bar is parallel to the surface. So the various parts are hardened and stabilized before grinding and lapping. So all the working surfaces of the bar and the cylindrical surfaces are fine to the surface of zero point 0.2 micrometers roughness value or some better things. So sine bars are graded as A grade or B grade sine bar. So A grade B grade sine bars with accuracy of 0.02 mm per meter of length. So these are various types of applications. So several if you do you will have D between two rollers the distance is L. So length of the rollers that means length of the sine bar distance between the rollers. So of the angle multiplied between the face plate which is the datum is given rollers. So what we are some object and right and we have a roller on the other way around we have this. So you have one more roller here. Okay, this is resting on the slip gauge. There is a slip gauge of a height it's a height h by L. You have to find out. So the principle of operation of sine bar is based on laws of other combination of slip gauges is inserted under the second roller. Okay, so then sine theta equal to h by L. That is equal to theta equal to sine. So for this reason, the device is called sine bar. Okay, to exist. So the axis of rollers must be parallel to and next one is the top surface of bar must have a high degree of flat rollers and the rollers must be of identical diameters and round within a closed tolerance. Bars these applications of sine bar means you have to find out the theta. You have to measure the angles. Okay, next so and next one is by using this theta we can easily find out the angle. So in this equipment the sine bars generally these angle measurement in the angle measurements concept sine bars coming to the sine bars so these sine bars are used for measuring the angles which are less than 45 degrees. So why we are not preferring to use sine bar for measuring angles more than 45 degrees? Because the accuracy of angle set by the sine bar depends upon the errors in its important dimensions, such as error in distance between the roller centers and errors in combination of slip gauges using for setting and error in parallelism between the gauging surface and the plane of roller axis, etc. So the slip gauge combination required to set an angle theta is given by h equal to L sin theta. That means sin theta equal to h by L. So the effects of error is spacing of roller centers or error in the combination of slip gauges on angular setting accuracy can be obtained. Okay, so so the above 45 degrees values tan theta sin theta however the effect become progressively more significant and generally it is not preferable for not use the sine bar for measuring the angles larger than 45 degrees if high accuracy is required. Okay, so some mm, and main features of this sine bar: the upper and lower surfaces are flat and parallel with respect to the datum surface, and side faces that means flatness, squareness to the upper surface and squareness to the axis of rollers, and those end faces are flatness, squareness to the upper surface, parallelism to the axis of rollers, and these are attached to the these are also uh, built with rollers, fixed rollers. These are having straightness, cylindrical accuracy, mean diameter also there. Okay, So this is the clear cut information about the angle measurements. So in this angle measurements, next angular instrument is Sine center. So due to difficulty of mounting conical work easily on the conventional sine bar, and sine centers are used. So here two blocks are shown in the figure, are mounted on the top of sine bar. These blocks accommodate centers and can be clamped at any position on the sine bar. So the centers can also be adjusted depending on the length of the conical workpiece to be held between the centers. So sine centers are extremely useful for the testing of conical work, since the centers ensure correct alignment of the workpiece. The procedure for its setting is same as that of for sine bar. Okay. Now sine table. So the sine table is the most convenient and accurate design for heavy workpiece. So the equipment consists of self-contained sine bar hinged at one roller and mounted on its datum surface. So the table is quite rigid and weight of unit and workpiece is given fuller and safer support. The table may be safely swing to at any angle from 0 to 90 degrees by pivoting it about its hinged end. Due to the work held axially between the centers, the angle of inclination will be half the included angle of the work. The use of sine centers and sine tables provides a convenient method of measuring the angle of taper plug gauge. Okay. So our next instrument is angle gauges. So angle gauges was developed by Dr. Tomlinson in 1941, which enable any angle to be set at nearest 3 inches. So these are the pieces of hardened and stabilized steel. The measuring faces are lapped and polished to a high degree of accuracy and flatness. They are 75 mm long and 16 mm wide and are available in two sets. One set consists of 12 pieces and a square block in three series of values of angle. So like 1 degree, 3 degree, 9 degree, 27 degree and 41 and 1, 3, 9 and 27 and 6 inches, 6, 18 inches and 30 inches. And another set contains 13 pieces and a square block. So 1 degree, 3 degree, 9 degree, 27 degrees and 41 degrees and 1 inch to 3 3 minutes, 9 minutes, 27 minutes and 3 inches, 6, 18, 30. So each angle gauge is accurate to within 1 second and is marked with engraved V, which indicates the direction of the inclined angle. So these gauges together with a square block can be so rung that any angle between the 0 to 360 degrees can be set. So each angle gauge is a wedge. Thus two gauges with their narrow ends together provide an angle which is the sum of the angles of individual gauges. So the subtraction of angles is obtained when the narrow ends are opposite as shown in this figure. So each angle gauge is marked with engraved V, which indicates the direction of included angle. When the angles of individual angle gauges are be added up, then the V of all should be in line, and when any angle is to be subtracted, its engraved V should be in the other direction. Okay, so general uses of angle gauges are widely used in industries for quick measurement of angles in between the two surfaces. So a frequent use of these gauges is to check whether the component is within its tolerance angle or otherwise. So where the angle to be measured exceeds 90 degrees, the use of precision square becomes essential. So the main limitations of this instrument is by combining the angle gauges, any angle could be made, but the block formed by the combination of number of these gauges is rather bulky and cannot always be conveniently applied to the work. So they are used as reference along with other angle measuring devices. So secondly, errors are easily compounded when angle blocks are rung in combination. So this is the clear cut information about the sine center, sine tables and angle gauges. Okay, and the next instrument is a clinometer. So clinometer is a spirit level mounted on a rotary member. So the angle of inclination of a rotary member relative to its base can be measured by a circular scale. Okay, so there are the various types of clinometers. uh, Vernier clinometer, it is shown in this figure. So it consists of a spirit level mounted on a rotary member carried in a housing. One face of the housing forms the base of the instrument, and there is a circular scale on the housing. The angle of inclination of rotary member relative to the base can be measured by a circular scale. So the scale may cover the whole circle or only the part of it. The kilometers are generally used to determine the angle included between the two adjacent faces of a workpiece. So the base of the instrument is placed on one of the surfaces and rotary member is adjusted till zero reading of the bubble is obtained. So the angle of rotation is then noted on the circular scale against an index. The instrument is then placed on the other surface and the reading is taken in the similar manner. If theta and pi are the reading of instrument, the included angle between the surface is alpha equal to 180 minus of theta minus pi. So this is the okay. So next clinometer is a micrometer clinometer. So in this type, the spirit level is attached at one end of the barrel of micrometer. So the other end of the spirit level is hinged on the base. So the base is placed on the surface whose inclination is to be measured. So here the micrometer is adjusted till the level is horizontal. So this type of clinometer is used for measuring the small angles. And the next clinometer is dial clinometer. So the dial clinometer is similar in the principle to the bevel protractor. So the spirit level is attached to a gear and a dial gauge. So the whole angle can be observed through an opening in the dial on the circular scale on the gear, and the fraction of the angle can be read on the dial gauge. Okay, and next clinometer is optical clinometer. So it consists of a rotatable turret which is mounted on the base. The spirit level is provided on the turret, and the readings are taken by measuring microscope on a graduated scale provided on a fixed circular glass disc concentric with a turret. So with this instrument, angle even equal to 1 minute can be measured. So the vernier scale is provided in this microscope. So overall, the Uses of clinometers are which are used for checking included angles, relief angles, as well as angular faces on large cutting tools and milling cutter inserts. So they can also be used for setting inclinable tables on jig boring machines and angular work on grinding machines, etc. So this is the information about the uh, clinometers. I will I will post the uh, one problem in our Google Classroom. Just practice it and see this diagram and use the theory as we have discussed earlier. Okay, so I hope everyone would understand this concept. And next coming lectures are with important topics are gauges. Okay, so I hope everyone understand this lecture, and tomorrow we will discuss about the gauges. Okay, thank you. Read well, stay home, stay safe. Bye.